Okay guys, so I'm going to take us through the principle of the monocopter. So once you understand this, you will be able to know how to model parts to be able to create what we want. So this is a monocopter. Now this, just like any other drone, should have yaw authority, roll authority and pitch, right? Now the monocopter, as you can see, it has one motor, just one motor. Now the motor, when it's rotating, causes a torque effect. So when the motor rotates clockwise, there's a torque effect that causes the motor to rotate anti-clockwise. If the motor rotates anti-clockwise, there's a torque effect that makes the motor rotate clockwise. So this propeller here, we are saying, is rotating anti-clockwise, which will create a torque effect clockwise, meaning that because the motor is attached to the drone would naturally want to rotate clockwise because of the anti-clockwise motion. Now we are supposed to create an opposite force in the anti-clockwise direction to cancel out this clockwise torque effect. Now to do that, we need these servos. Now these servos, they can rotate like this, right? So depending on which direction it's going, when it tilts one direction, it creates a force in the opposite direction. When it tilts the other direction, it creates a force in the opposite direction. So if you want these servos to counteract or stop this force, clockwise force, that means you have to create a clockwise direction or rotation to create an anti-clockwise reaction, right? So for us to cancel this, we have to rotate the servos clockwise this way. Right? When we rotate it this way, it's going to create a force in the opposite direction, which will cancel out this. So it's like when this is coming this way, the force will be coming this way to meet it. So in doing that, we are able to control yaw, because we can stop yaw, but we can also reduce the forces against it and cause it to yaw clockwise, as well as increase the forces and cause it to yaw anti-clockwise. So we control yaw using these four servos, all rotating the same direction to either increase torque effects or cancel out torque effects and create yaw rotation. Alright, so now we know how to control our yaw using four servos, all tilting against the direction that we don't want. Let's go to roll. How does the monocopter roll? So let's take roll as this. Let's use this plane. This plane. So roll will cause things to go left and right. Okay. So if it is moving left and right, that is roll. So how can we cause this craft to move left or right? So to do that, we are supposed to use two of these servos. Now what happens is, see, I told you when the servo tilts in one direction, it creates the force in the opposite direction. Now when it creates a force in the opposite direction, what happens is, let's take this like a stick with a pivot here, and then this can rotate this way. Now when this thing is this way, right, and the force is created this way, it forces this joint to move this way and causes the top here to move the other way. Okay, so for row left and right, the two servos that are aligned should move all in the same direction to cause the drone stop to move either this way or the other way. If you want to control pitch is also the same. So this time the axis is this, the horizontal one. When both of them move in one direction, it causes the drone stop to move, especially in that particular direction. Then when it goes the other way, it causes the rotation the other way. So for roll and roll pitch, this is how it works. Okay, so when the base is shifted this way, it causes the top to move the other way. So this is right, this is left. Okay, so basically that's it. So the next is for you to be able to get the right control surface length or area, so the right one or the right distance from the motor props to the servo control rods, which is linked to the control surface. So let's see, we'll look at that in the next video. Okay, so for us to start the construction, you have to understand a little basics, right? Now the diameter of your monocopter will depend on the prop size you are using. So that's the first thing you consider. Now you also have to take note that aside the diameter, you have to add some tolerance so that the propeller doesn't hit the walls, so that you are creating an enclosure or just boundaries or an enclosure. There has to be some tolerance. So the prop size, let's say 5 inches plus 10 millimeters, so that there will be 5 at the ends. Okay, then once you know that, the next is the distance from the motor props here to where the servos should be mounted. So usually I'll leave 30 millimeters, but in total, if you're able to leave a gap of 80 millimeters, should be fine. The prop shouldn't be so close to the control surfaces. Okay, so once you have this gap, then note that the prop end here to the motor's mountain will add up to this to be able to give you this. So that one, to depending on your motor sets, should be having something around this, maybe less or more. Okay, then the next consideration is your control surface area, right? You want to give it as much area as possible, because the longer it is, the more authority it has, or the bigger it is, the more authority it has. But I don't want to go and make it so long, because your servos may not be that powerful. You don't want to make it short, because your control will be a bit limited. It will make it unstable. Okay, so for this particular length, actually let me make it 10 inches. For a 10 inches, this is what I'll choose. 100 millimeters for the control length, then the gap of this. Yeah, so this is based on my monocopter. If you are using something like 5 inches prop, then yours can add like 6 millimeters for the diameter. Then this length can even be 50, so you can leave like 10 or 20 here. Your control length can be 60 millimeters. And then this is for the length of your leg, so meaning the leg has to be longer than where the control surface ends. That one, it depends on you. Okay, then after getting this part right, the top will be the mounting for your flight controller, and that one you're advised to use rubber gamuts so that whatever vibrations can be dampened before they get to the flight controller. Then there has to be another mounting. That one can either be from here or from here, just for the battery to be mounted. So a mounting for the battery. Your servo motor wires will pass somewhere here and come to the flight controller. The power, maybe you are using a beck or something, they will all be around this place. If you have the ESCs, if it's a 4-in-1, it will be under. If it is single, you can bring them, but there is just one, so you can be under. You can create a space here so that the ESC will be under. Okay, now as you have the length, the width, there's one important thing you have to take note. The control surface is not supposed to be properly from end to end, because you realize that even the motor, there is a shaft here, so all this place almost to the diameter of the motor, there's not much authority here, so you want to make it slim. So if this distance is half of the prop, you can minus 10 millimeters from it and let it be your weight. Then you need to slant it, otherwise, you see there are 4 servos. When they all tilt in the same direction, you are safe, but once they tilt in opposite directions, when they are controlling your roll and pitch, they might collide. So slanting the control surface will prevent that. And also making the later end being small reduces stresses on the servo. Okay, so that's one point that you have to note when you are designing or choosing your control surface. Okay, so from here we will move straight to modeling of the monocopter, and then we'll look at how to configure it with the electronics.